So in the last video, we have discussed about the different types of indicators, natural indicators, and also the chemical indicators, the olfactory indicators, etc. So today, let us move on and learn about the chemical properties of acids and bases. So when we talk about the chemical properties of acids and bases, we have different types of reactions, in which the first one is reaction with metals. So how does the acids and bases will react with metals? Let us see. So when acids react with metals, they will form salt and hydrogen gas. So in order to understand this, a small activity has been demonstrated in your book. So let us see what the activity says. So take a test tube in which you take dilute sulfuric acid, and then you add few zinc granules to that and allow the reaction to take place, after which a gas will be evolved. So that gas is sent through this bent glass tube into the soap solution. Okay, here why we are using soap solution is the gas that is coming out can escape off very easily before we can perform any test on that. So in order to avoid that, we use soap solution in which the soap will form a thin elastic coating around the gas and will make the gas to remain in the form of a bubble for a longer period. Okay, so whatever bubbles that are coming out, these are the gas bubbles from the soap water. So what you have to do, you take a candle, a lighted candle, and then take it near the gas bubble. What will happen? The gas bubble will burn vigorously and will produce a pop sound, which is the characteristic feature of which gas? Yes, it is hydrogen gas. So this indicates that hydrogen gas is getting liberated when your sulfuric acid reacts with zinc granules or a metal. Okay, so what is happening? You can see through this equation. So sulfuric acid, when it reacts with zinc granules, it forms zinc sulfate and also hydrogen gas, which can be tested with the famous pop sound test. Then next we have is reaction with any of the other acids also, the reaction would be same. Like in the case of hydrochloric acid, reaction with zinc, it will produce zinc chloride and hydrogen gas. Okay, and acetic acid, if you take, it will react with zinc, forming zinc acetate, and hydrogen gas is getting liberated. But one exception you have to remember, that is with nitric acid. So when zinc granules react with dilute nitric acid, they produce zinc nitrate, and the gas that is getting released is not hydrogen, it is nitric oxide, and water would be produced. Because nitric acid actually is a strong oxidizing agent. Here hydrogen is not getting produced. So you have to remember this exception when you talk about reaction of acids with metals. Okay, so likewise when we talk about reaction of the bases with the metals, will react with only some metals like zinc and aluminium. What is the speciality of zinc and aluminium? Zinc and aluminium, they are called the amphoteric metals. What are amphoteric metals? The metals which can react with strong bases and acids. Both of them are called the amphoteric metals. So here we have zinc and aluminium, which are amphoteric metals. Here, in your book an activity is given wherein to sodium hydroxide, you will add few zinc granules and you have the formation of sodium zincate and hydrogen gas. So what we will observe is when the bases are reacting with zinc or aluminium also, they will be producing salt and also hydrogen gas. And again, to test hydrogen gas, same pop sound test can be used. So similarly, sodium hydroxide, which is a strong base, will react with aluminium in the presence of water, giving rise to sodium aluminate and hydrogen gas. So most other metals, you have to remember that they will not react with the bases. So only few metals will react with the bases, but most other metals will not react with the bases. So this is about the reactivity of acids and bases with the metals. So let us talk about the second important chemical property, that is reaction of acids and bases with metal carbonates or metal hydrogen carbonates. What will happen? So when you see about acids, when acids react with the metal carbonates or metal hydrogen carbonates, what is the reaction? You have formation of salt, water and carbon dioxide. While bases will not have any reaction with these. So there is no reaction of bases with any of these. So let us further see about how the reaction goes about with acids. Okay, so there is an activity in your textbook wherein we have to take two test tubes. In one of the test tube you take sodium carbonate, in another one you take sodium hydrogen carbonate, which is a metal hydrogen carbonate. To both of them we will add hydrochloric acid, because we are seeing the reaction of the acids with the hydrogen carbonates and also the metal carbonates. So how it goes about? So sodium carbonate and sodium hydrogen carbonate are taken in different test tubes to which you are adding HCl. What will happen, as you know, salt water and carbon dioxide gets formed. So in test tube A, we have the formation of sodium chloride, we have formation of water and carbon dioxide, while in test tube B, we have the formation of sodium chloride, water and carbon dioxide again. So this carbon dioxide gas that is getting evolved, when it is passed through lime water, okay, how it will become, if you remember, it turns milky, which is the test for the carbon dioxide gas that is getting evolved during this reaction. Okay, and then further when we talk about carbon dioxide is turning lime water milky. So what will happen? So when carbon dioxide is passed through lime water, which is your calcium hydroxide, it turns milky. If you remember why it turns milky due to formation of calcium carbonate, okay, which is your other name for your limestone or your chalk or marble, okay, that represents different forms of calcium carbonate, and also you have formation of water, okay. So what is the thing what you have to observe here is calcium carbonate in water. When through that, if you pass excess of carbon dioxide through that, what will happen? It will result in the formation of calcium hydrogen carbonate, which is soluble, whereas your limestone is not soluble, whereas calcium hydrogen carbonate is soluble in nature. So this soluble nature of calcium hydrogen carbonate, okay, if you see, is actually responsible for formation of caves and stalactites. You know what are stalactites? So along the roofs of the caves, you have some hangings, deposits of minerals will be forming some hangings in the caves. So these are called stalactites. So actually what will happen is rainwater, which contains dissolved carbon dioxide that is taken from air and also from the soil, will form a weak carbonic acid. Okay, so is coming into contact with rainwater, slowly the limestone material, okay, will get solubilized and it will result in the formation of the caves and stalactites. So that is the significance of this particular reaction, wherein calcium carbonate in water, when excess carbon dioxide is passed through that, okay, it is resulting in the formation of soluble hydrogen carbonate, which is actually responsible for formation of the caves and also stalactites because of dissolution of limestone in rainwater. So hope you understood, and you have to remember that there is no reaction of the bases with the metal carbonates or, okay, the hydrogen carbonates of the metal.